day 19 with more texture atlas automation to do. Generated. Alright. So I've got all this, and we need more stuff to be done here. Alright. So presumably that's just all of this commented out stuff, right? Yeah, so it looks like we are filling an array of animations. We are also filling atlas locations. Like this has to be somewhere, right? Okay, so what does that mean? Alright, well, yeah, animation, I mean, so right now animations are kind of build up at startup, but that really shouldn't. Animations, yeah, so that should probably just be a global array, like just in here. Probably. Okay, so the way that would work then is, well, we aren't gonna do this here. We're just gonna get all the stuff out of a sprite, and that'll be it. We'll just get it out of there. Yeah, v2 first frame offset, yeah. Well, basically, yeah, we want to comment all of this out. I mean, in. Animations need to be set somewhere else. Okay, what is this working at? So we know there's going to be some shared code between shared, let's see, oh, I guess common. So let's just pull out everything that's common to the build program and to the main program. Well, asprite for now is common. That's not common. Read entire file will be common. Write entire file, well, not right now, we don't need to write anything. This is all specific to the build program. String builder is specific to the build program. Yeah, string slice. Okay, so this stuff to do with strings and memory, yeah, that should probably be pulled out. Yeah, let's pull this out. Int, so not assert, assert's a different. And not that, that's different. Str, unused, array count, arpo, shall array now, array temp memory block. So all of this stuff could be in the common section. Include common.c. Yeah, so all these includes don't need to be there. Well, actually, hold on. This is not uncommon. There. This is, though. Okay, so assert includes These type defs should go in here. Common, enough. Memory. Yeah, I reckon all of memory should just be here. What we don't have string.h anywhere. The assert. Oh yeah, assert should be defined before. That's right. I mean, I guess that could just be the default. There we go. Strings, yeah, let's just pull them into common. Sprite, then read entire file in MISC. All right. And yeah, all right. Yeah, we'll figure this. We need to figure something out about. Okay, attribute format. Yeah, so let's just see what the definition of that is. The definition of that is apparently this. Okay, we also need stdarg. We are relying on stdprintf. Oh yeah, so we do need to include that in here. Yeah, if string formatting is going to be in the comment section, then this has to be here. Yeah. Alright, so should we just include windows.h in here then? Maybe. Well, maybe not. Actually, maybe that should be in a separate file. New file, common, Windows. Yeah, splitting code into multiple files is always kind of an exercise in I mean, we could just make it be not self-contained. Let's see how well that's handled by... Like, what happens here? So that's just completely busted. But what if we just included... Oops. Okay, so asprite is in the common section, so all of this goes away. We have that read entire file here. So we could do it this way, right? Just include Windows dash in common windows. And then include common windows. And do it this way. And then remove the entire file from here. Of course, it'd be nice if it could just realize the context that it's in. Like this stuff, right, is... Like, it's not... It's like, yeah, this is happening because it's not self-contained. But, like, I kinda don't want it to be self-contained. So... let's see, is there a way to avoid having to have forward declarations and having to synchronize those? Is there a way? I mean, this is the way. This is the way. Except that language support doesn't like it. We could just turn that off, I guess. And maybe we can just have to do that. Because if it can't handle non-self-contained files, then it can't handle non-self-contained files. It can, I can't use it. Okay, let's look at this again. This is all fine. String formatting, everyone needs that. Yes. Type defs, these type defs, everyone needs those. Memory, everyone needs that. String, just basic string stuff, everyone needs that. Asprite, well, Asprite is gonna go away. But like these three sections at least need to be here. Turning off language support though. Well, let's see. I guess I'm just gonna have to do that. C plus. Well, I mean, is it like X, C, PP? It looks like it's that one. Okay, IntelliSense. Autocomplete, configuration warnings, code faulting, default standards, defines, .config, enable configuration squiggles, IntelliSense mode. How about you just turn that off? Enhanced colorization. Error squiggles. Modified in workspace. Well, I'm guessing that's just disabled, right? Yeah. Extension, CPP. Yeah. Exclusion policy. Check folders. Hover. Inlay hints. IntelliSense engine. Fallback. Markdown snippets. Parsing. Clang format, path, clang format includes clang for formatting. That's all formatting. Yeah, all of this is formatting. Simplify structure. Client ID checks disabled, client ID checks enabled. Yeah, client ID enabled. No. How about we disable that? Experimental features. Case sensitive file support. Max memory, max concurrent threads. IntelliSense memory limit, cache size, path, max memory. Okay, well this is still coming from somewhere. Client diagnostic error. Can I turn that off? No. No. Okay, a lot of formatting. Well, presumably somewhere in here there is something I can turn off. Although if it's not picking the... Like if it can't handle non-self-contained files, then it's not gonna provide... It's not gonna provide any kind of support, right? It's not gonna provide macro expansion. It's not gonna provide go to definition. I mean, client ID should probably just be disabled, to be honest. Yeah, it's that one. Yeah. Non-self-contained files. Although, well, I mean, if I just put that here, that will fix it. That will fix it. Of course, now we have Windows.h included, right at the top. Well, we'll see if that's a real problem, and maybe we'll fix it. Okay. Yeah. So, what's in common? All this stuff. Oh yeah, this should probably be in common as well. Include common.c. There should be a bunch of... Right, so what do we not need? Oh yeah, these stringifys should be in here probably. Assert is different. All of this is already defined. That isn't. This is... This can go away, that can go away, this can go away, this can go away. String slice should be in strings. Capitalize. Leave it here. Capitalize string builder, just leave that stuff here. Write entire file. Builder. Yeah, that can stay. Oops. Let's include stdlib at the top. Okay, well, ace file is now included in common there. So, yeah, I mean, it's right here. Do I need to rename it to .h so it knows what it is? Like, is that some kind of language support thing? It just refuses to, like it's clearly here. Come on. Well, Atlas ID and stuff, yeah, that's not gonna work for us. So let's comment this out. Okay, well, those are just wrong. Oh. Oh, that's interesting. So we want to include this thing. And we want that to be the assert definition. Is this sort of thing is what it's not? Oh, okay. Oh, it's using a string though, right? Well, it's using a bunch of things here, yeah. It's like we want to include Windows.h before, but also we don't. Yeah, no, we do kind of want it to be like this. Oh my god. It's like this definition needs to be above, unless no, it kind of does. We want to know how long it is. be incomplete. So we need the full definition to appear before the thing. Or we could just define the assert in a way that doesn't require me to do this. Such as... Oh, let's see. Well, we still need to call write file. At the very least. Well, essentially that. Yeah, well, that's not a thing anymore. Yeah, so there's still the problem that yes, the output handle is undefined. I mean, we know what it is. Write file is undefined. We could define it. Just have forward declaration here. Well, let's see if that's even possible. Oh, what? Nah, it's probably gonna say it's conflicting definitions or something. And bool is int. Yeah. Well, almost though. So what is conflicting exactly? Just out of curiosity, like what is conflicting? Mm. Yeah, but this also needs to call write file. Yeah, whatever you do here. Oh my god, can't even comment it out properly. Let's just make sure that. Yeah. Okay, so that much compiles. If only language support would realize that it compiles, that would be pretty good. Alright. Yeah, the assert definitely needs to be redefined somehow. The question is, how do I redefine the assert such that it also uses well, I guess I don't really have much of a choice. I guess I do have to do this. And just copy what we had before that. Yeah, essentially just, well, this, include windows.h, define write to stdout. There, include windows.h, define write to stdout, define the assert, and then include common. So all of this needs to happen. Before including common. Does that compile? No. No, because we're using string here. Well, I mean, I guess we don't really have to, right? Well, except we kind of do have to, a little bit. Does that compile? Kind of. Oh my god. Brackets are in the wrong place. Okay, well, that does compile. At least, so that's something. Great success has been achieved. More or less. Yeah, apparently I don't use write to stdout anywhere else, just there. Assert write to stdout. Yeah. I mean, at this point I might as well just copy that. Okay, I suppose I need to make sure that it actually works. Insertion failure. Yeah, there it is. Works. It works. Yeah, that'll do. String builder. Place that. Right. Right, entire file is here, bench, okay. So all of this is the main program. Okay, that's fine. Yeah, this should also migrate over, so that was kind of the whole point. I guess I should just say that, yeah, that's what happened. We just pulled out common code. Yeah. Pull out common code. Are we still working? Actually, oh my god. We're still working. We are. Alright. Commit, sync. Alright. So now to uncomment some of this, finally. Okay, so I kind of want to run it here, right? Is all of this like capable of running? Well, there are problems. There are problems. Yeah, these are the problems. Okay, well, v2, that should probably be in common, because we are going to be storing those. Oh my god. Common. Yeah, alright. Alright, so v2 is fixed. Everything else is not. Things like textures, yeah, well, texture is something that we're gonna be storing, probably. Yeah, so we use this for Atlas location. Yeah, so Atlas locations is something, yeah, Atlas locations need to be common. Which means rect needs to be common. Just a bunch of errors. Well, Atlas ID, obviously, that's something we're generating here, so we're not going to be using that. Texture. Alright, so what's gonna happen is we're processing these files. Yeah, the processing should happen after the sorting. Should it? Well, no, because we can parse them right away. Just we don't know what the ID is, but we can just stick everything into this info struct. So anything that relies on this ID is just not going to be in there. Texture needs to be pulled out, seemingly. STP image actually needs to be pulled out into commonness. Well, yeah. For now, it's gonna be common. Rectpack, yeah, probably also rectpack. Alright, so there's only one arena. So we do this, and there we go. We just need to save the texture, is the point here. Well, that's easy enough. File info, we can just say texture. Well, there's multiple per frame. And we know how many frames there are because of that. So texture, textures. So we can just do that. Yeah. Alright, so as soon as we have this, we can say info, textures, arena, alloc array, arena, ace, frame count. So there's one per frame. Alright, and in here we'll just say info textures frame index is texture. Yeah, so I should probably zero this. Array, alloc and zero array, alloc and zero. Alright. And zero. Arena alloc. Arena size. Memset. Pointer zero size. Alloc and zero. And just before setting it, I want to make sure that assert info textures frame index pixels is 0. Just assert it's not been set before. Atlas location, that's another thing we need to save. Yeah, except that this is one of those we need to know how many. So Atlas locations. Yeah. So we need to know how many there are, so perhaps this processing does need to happen after. And then we'll just fill out the atlas locations, because that's per texture. That's per texture. Well, that's per atlas ID, really. So per atlas ID, there is a texture and there is a location. Yeah, so, alright. So these textures aren't going to live here then. So that's not happening. What is happening though is we're going to sort them. And now, once we've sorted them, we know that the IDs will go in the same order as what we've got as the file infos. So we can just iterate through the file infos. And then everything down from here can happen in just in here. Something like that. Okay, frame. Alright. Ace file, ace is info content. Something like this. Alright. So that's entity IDs, alright. And it's gonna even happen like after all this easier stuff, like here, let's say. So we start iterating, we go in, alright. So info textures is not a thing anymore. Yeah, alright. File info index, frame index. So like right here, well, it's not even here really, it's like outside. We can say i32 current atlas ID index. Well, yeah, let's just call it that. Is 0, and then it's just incremented every time through this inner loop, which is here. Well, I mean, no, it's incremented every time we actually find a texture. So like here. Yeah. And at this point, we can fill the textures. Texture, Atlas textures, alloc array, arena texture, and what do we... well, let's... actually, do we know how many? I mean, right here, when we're building out this Atlas ID enum, we kind of can just total texture count 0, total texture count, I mean total Atlas texture count, I suppose. We can just save that. And now that we know how many textures there are, we can allocate that, and we can allocate Atlas locations as well. Current Atlas ID index. There we go. Some of it is now working. Alright, the only thing that's not working is this. Alright, so we need to assert that current Atlas ID index is less than total Atlas texture count, and then we can just say Atlas textures, Atlas textures current Atlas ID index equals texture. Yeah, so we can just save it into that. Nice and simple, yeah. v2 sub needs to be in common, evidently. Yeah. Well, this compiles, actually. This compiles. Which means we're saving locations and textures. So now, if I just process them in the same way that they're being processed here, it should be good. Except that we have that white pixel and font, right, sitting in the Atlas, which will be accounted for. There. Yes, it will be accounted for. How are we keeping track of that stuff here? No, just through IDs. That's right. And if I were to replicate that here, that would mean that the first one should be the white pixel, the second one should be the font. Which I guess I could even do something like this. Builder add count. Right, then I don't, I can just snap them. Alright. Well, let's implement that part. That's easy. Add count. Begin. Okay, so now we know how many textures we've added. We allocate that many. So what's happening here then is well, atlas locations are filled in later. Okay, so we allocate that many textures. Then we need to do something like this, right? We need to handle the white pixel. Well, yeah, we kind of need to keep track of, yeah. Struct texture pointer i64 length capacity atlas textures capacity total atlas texture count. Then pointer set that, then rpush atlas textures white pixel texture. There. Alright. So that's kind of like this. Oh, that's the equivalent. Then the same for font. Okay, so there is the textures. There is the font. Obviously font texture should be pushed in rpush. atlas textures font texture. Okay, so basically this part and this part, that works. So here it's synchronized through IDs, here it's just synchronized through the fact that it's in the same order as what's in the enum. I mean, sure, good enough. Well, I guess we'll see if it's good enough. White pixel font, and then after that it's the main. That's the main part, which is this stuff. So current atlas ID index, we don't actually need to keep track of that. Because that's kind of being kept track of automatically. In the length field. Atlas locations, on the other hand. Okay, that needs to be zeroed. Okay, so this location is actually atlas textures length. So it's that. Right. Okay, that compiles and runs without crashing. Right? Yes. Yes, yes. Okay. Well, given that compiles and runs, okay, we don't need to do bounce check there because of that capacity being synchronized. Yeah. Okay. Well, at this point we have all the locations and we have all the textures. The locations just have a rect and an offset. Yeah, the offset has been set to 0, and when it hasn't been set to 0, it was pulled out of the file. So now we just need to pack them into the rectangle, which is this stuff. Yeah, so we have the locations, we have the textures. Let's go in and just pack them in. That would be this stuff. Yeah, all of this. Which means we are including rectpack in common for now. Okay, so we go in rect to pack, rects to pack. Textures length. Okay, so this is atlas textures. Well, at this point we need to make sure that atlas textures length is atlas textures capacity, because we should have read all of them in. Yeah, if everything went correctly, we should have read all of them in. Alright. Textures. Hello, chatter. Textures is atlas textures. Well, actually, I should probably just rename atlas textures. Locations, is it just an array? Yes. Alright, so there is an insertion failure. Let's find out why that is. So length is 6, capacity is 7. Seven. Well, let's see, how many should we have? White pixel font, that's 2. Then 4, 5, 6, 7. No, there's 7. There's 7. Which one are we not accounting for? I mean, by the time we go in here, length is 2. There are 3 of these. We're in one of them. It's got 1 frame, so that should be 4 on the next time we hit this. So now it's add to watch. Length is 2 still. Okay, length is 2. Oh, it just, alright. Now length is 3. Alright, now we're in walk, which has 2 frames. Yes. Now we're in now we've added it. Next time we hit it, we're in, should be in the 2nd frame. Yes, 2nd frame of walk. Yes. Wait. 7. White pixel font plus 4. No, that's 6. Wait, no, 6 is correct. How did we get to 7? Total atlas texture count. Oh wait. There. Okay, now it's not asserting anywhere. So we get down here. Textures, length equals capacity, so we have accounted for all of them. So we pack them in, and that gives us the atlas. We already have the locations, which are further updated here. this time for all of the rectangles. Okay, so there we go, we've got the atlas. We've got the atlas locations. Can we pull all of this code out of here now and just read the file? Well, first of all, we need to write that out. Yeah, atlas textures we don't need to write out because we're putting them into the atlas. Alright. Well, alright, so what we have to write is the atlas itself and the locations associated with it at the very least, and then just read that in. Read that in here. Well, first, I mean, I guess it would be easiest for now to just write entire file arena path. Alright, well, code, well, data data.bin, let's say. Atlas pixels, atlas pixel, well, size of atlas pixels times atlas width times atlas height. Okay. Does that write something? Yeah, it does. It does. It writes out that data.bin. Data. Okay, so data.bin is 95 kilobytes. Okay. Yeah, that seems about right. Alright. So given this atlas, let's just read in the atlas instead of constructing it. Well, actually, we still construct it. But then we'll just pull a switcheroo. Yeah, like right here. Atlas pixels. Read entire file. Arena data.bin. U8 array data atlas pixels is data. We'll just set it, just cast it. Well, first of all, assert that data length is at, well, size of atlas pixels dereferenced times atlas.h times atlas.w. Something like that. Yeah, it is. Alright, so it seems to be... So this is the replaced atlas, and it seems to be working. Well, if the replaced atlas is working, well, let's make sure in RenderDoc, I suppose, that it's actually working. Launch application, launch, capture, quit, inputs to the first color pass. Yeah, that is the correct thing, I think. Except for the I mean, I guess this is how it was before as well. There's the white pixel. That's the null. Yeah, I think that's the null character. Yeah. And that's a space or something. Yeah, okay. Well, fair enough. Then what? Well, we need to store not just pixels for the atlas, we need to store the dimensions. So, what's this gonna be? Like, well, it's kind of like a string builder, except it's a binary file builder. Bin builder. What do I call it? Bin B. Well, how am I handling string builder? String builder is that. Pointer length capacity. Well, we don't really need much else there. Bin builder also will be pointer length capacity. Capacity is, I don't know, 50 megabytes or something. Doesn't really matter. And bin write the width, I guess. Atlas width. Atlas height. I mean, this is, we're writing an I32, right? Width, height, write U8 array, atlas pixels, and then the size. That. Alright. Then write I32, bin builder, bin, sure, I32 value, and write U8 array, U8 star, well, I guess U8 star, pointer, I64 length, and this is just gonna be bin write perhaps there should just be bin write val. bin right, bin bin val bin val size of val memcopy bin pointer plus bin length source pointer size length. Alright. Assert that bin capacity minus bin length is greater or equal to length. Okay, so that should be fine. Okay, does that compile? It compiles. Okay, so that's not gonna run though. Well, actually it will. Hold on. Bin b pointer bin b length. Okay, so write width, height, and then the pixels. Okay, so that's gonna work, but that should crash because the size shouldn't match. No, the size still matches somehow. Okay, well, that's interesting. Why would it match? Why would it match? Nine five seven six zero. Bin right. Oh, I didn't actually write anything. I think that's what happened. Bin length plus equals length. Yeah, there it is. Wait, hold on. Is it? Is it? No, it's still somehow working. No, it's crashing. I just didn't pick up on that. Oh. And somehow that just worked. I mean, it didn't. It was crashing. I just didn't see. I just didn't see it crash. Pointer is arena alloc array. No. Arena type u8 count as bin b capacity. I mean, that is kind of a problem that you can just execute something and it crashes, but you don't see it crash. That's weird. Okay, now there we go. So that length is not the same, so it's 8 bytes more. So this common.c, well, I mean, it's not even really common.c, right? So somehow we need to write these things out in the same way that we're gonna parse them, essentially. And is there a way to, like, I mean, I guess there is, right? If you just go to common, and then you just say type def struct asset data. Why not? And in here you just go struct i32 width. Well, I mean it's just the well it can't really be texture, right? Because it's like i32 width height, and then it's some unknown amount of pixels. And then it's some unknown amount of pixels. And this isn't necessarily the only array that's going to be in there. Well, let's try it. Let's try it anyway. I mean, we kind of know how many pixels there are in the asset data. So, can't we just generate it? It's an interesting idea. What if we just generate it? I'm gonna go take a toilet break and think about this. Yeah, so what I'm thinking is this binary writer thing can just keep track of what it's writing and generate a type based on that. And we can just write out that type, cast it here, and just use it. Alright. So what would that look like? Well, I mean, we kind of need to change how we're using it. So bin builder is going to be different. So it's pointer length, capacity, yes, well, kind of. I mean, this could be like the lower level. And type def, struct, asset, data writer. So this is going to have actually a both. It's going to have a bin builder, bin, and it's going to have a string builder, str. So that. Alright, and then we just do asset data writer is data build, oh, I guess builder, sure. Calling them builders. Data builder is what bin builder and the builder. Okay, those are confusing names, to be sure. Well, can we rename this to str builder? Can we rename this to str builder? Oh, fuck's sake. Right. So we take this asset data builder and then we ask it to like asset begin struct, well, asset begin the asset begin and asset end at the end. Begin struct as atlas okay, well that's not going to be happening anymore. And struct asset add field width. Well, I guess we can just put it in here, whatever. Name and type. And then just atlas width. Width, height. Yeah, and this one is gonna be asset field pixels. Well, actually, U32 well, I suppose I could just use ints here. And unsigned int here. Unsigned int pixels, and I can just put how many there are in here. Str format arena, and this would be size of dereferenced atlas. Well, actually, not even dereference. No, this is yeah, atlas width times atlas height. Yeah, so add field to the type definition and write this data. Add field to the type definition and write this data. So well, so add this field to the type definition and write atlas pixels size of dereferenced atlas pixels times atlas width times atlas height. And write this data. Alright. Okay, so I think I know how to do this. So this would be static void asset begin asset data builder data builder, and this would be str builder begin struct. Yes. Yeah, it's probably useful to just have that there. Data builder str, and the struct name is asset data. And we don't need to write anything. Builder and struct. Of course, structs can have nested structs. Well, I guess enums are a bit easier than structs. So let's just write this out manually. So this is gonna be builder format build data builder str type def struct asset data open new line builder format, by the way, it should probably be str builder format type def struct asset data, and this would be asset data, like that. Asset begin, asset end. Okay, and now we've got asset begin struct. All of them will be like this. static void begin struct str name, that's just this. Struct current struct, because really the name is the value name. Which, I mean, I guess instead of doing it this way, we could just follow how the definitions go and just do it this way instead. So instead of begin, this would be end, str name, and then just %.s name, semicolon, name, just that. Okay, begin struct, end struct, so that just goes in here. That's just a data definition thing. Okay, add field. I mean, sure, add field, why not? Oh my god, what? Static void asset add field underscore. So this is gonna be asset add field, then str field, I guess name, and then void star data and i64 data length. Yeah, so this is where the synchronization happens. So we need to do something like that. So what are we writing? We're writing the name. And then bin write data builder bin data length there. I mean, I guess I can do the same thing here. Define asset add field data builder name and then data, well, name value, and we just do this data builder, then str name, and then address of value, and then size of value, like that. I don't even need this. Okay, string int size of int. Yeah, that works. Add field, and struct. Okay, does that work? Kind of. Alright. So some errors, evidently, in generated code. Alright. Well, alright, so multiple things going on there. First of all, that struct needs to be indented. And I guess these fields be indented some more. Then what on earth is happening here? I don't know. Lit int height unsigned int pixels. Okay, so that seems correct to me. That is what we are writing. Okay, now we should just be able to cast it then. Data length asserted it's the size of asset data. And then just cast it. Data asset data is asset data data pointer. Okay, so do the cast and then just do atlas width is asset data atlas width, atlas height is asset data atlas height, and atlas pixels is asset data atlas pixels. Does that work? Maybe. Yeah, seemingly that does work. Huh. Well, in that case, we can just remove a lot of this, not all of it though, but a lot of it. Because Atlas is simply created here, so like, we can just move it down here, right? Packing is happening elsewhere, this is happening elsewhere, this is happening elsewhere. Locations, well actually no, not quite, right? Because locations is the other thing we need to write in. And what's that gonna be like? It's gonna be like int, like count, I guess length. And atlas location, locations. Hey, well, I mean, I guess I could just say that. Well, actually, we know how many locations there are just from, like, we don't even need to wrap it in a struct or anything. We can just say atlas location locations, and then just write atlas locations, size of atlas locations times what? Total atlas texture count. Yeah, that's what I call it. Total atlas texture count. Okay, well that's to write the data. That's to write the data. But what's the name? Well, let's see. Okay. Okay, well the formatting is wrong. But total atlas texture count. Okay, so this is not self-contained, but it doesn't seem to be generating errors, so that's good at least. Alright, so now we just need to make this a little more sophisticated. If we are inside a struct, I mean, we just need to keep track of current indentation level, right? I32 current int level. Asset begin, and then just do data b current int level plus equals 1. Data b current int level minus equals 1. Begin struct, so like asset indent data b, so indent first, and then do that, and then data b current int level plus equals 1. Asset end means we need to reduce the indentation level first, then indent, and then add this. Okay, so asset indent and then just yeah, we're done there. Okay, static void asset indent would be for I32 index is 0, index is less than data b current indent level index plus plus, str builder format data b string, just do that essentially. Current build indent level is 0. Okay, well that works. So that is the atlas. That is the atlas locations. Well, actually, locations should probably go inside the atlas. Now that I look at it. Like that. And clearly this arrays stuff is something we're going to be adding a fair amount, so let's help ourselves out here a little bit. Asset add array field. Data name. Okay, so we want data name. And then count void star data, I guess I64 data, like element size and element count, maybe. asset add field. So that's gonna just be data builder name data. Well, actually not name. No, we're gonna have to write this out. Okay, so indent first, then format. I mean, I guess I can just make it 132. Yeah, because integer literals are limited, you know. So, alright. So that's name, and then element count. There we go. So that works. Bin write. What are we writing? We're writing data element count times element size. Okay, so asset add R field. Okay, so name would be unsigned int pixels. That is element count. That is element count, and that is element size. Name data name data element size element count. Name data element size element count. Alright, so here we can kind of see how it works out. So we can do another one of these. Defines data b name data count there, and we can just call this and give it data b str name data, then element size and element count. Alright, so that to be name atlas pixels. Oops. There. Data v string name pixels element size element count. Okay, that seems to be working for me. Alright. And okay, that's working. Alright. Now we just need to copy over locations, which is here, right? Atlas locations pointer. So Atlas, and then we do assert. Well, Atlas locate of Atlas locations. Length is array count, and that's asset data atlas locations, atlas locations pointer is asset data atlas locations. Okay, so if we see stuff, that means it's correct, yeah. Length is 6, yeah, that is correct. Okay, so we're passing in locations. We're passing in the atlas itself and its dimensions. Okay, is there anything else we're getting out of this? I mean, I think this should mean that we should be able to remove offsets. Well, we're just straight up replacing. Oh, hold on. Oh, Yeah, we can't really overwrite this stuff because location is something we need to keep. So we read this. Yeah, we need to read this file in once and just keep it forever. At startup, let's say. We don't need to stream anything. We don't have enough assets to justify really doing that. There you go, just as soon as we have some memory, just read the assets. That's what we're going to be doing into permanent storage. Alright, now at this point, since we have locations, what are we doing here? So this is setting locations. So I think we can get rid of that and not worry about it. Yeah. This atlas creation. Okay, so this is already happening elsewhere. We already know how big the atlas is. We don't need to back anything. Yeah, which means that we can remove STV rectpack and STV image from here, I think. So this STB decode buffer thing, that doesn't need to happen really. We don't need to be decoding this stuff because we don't actually need this texture array because we already have the atlas. So we don't need this, we don't need this. We don't need any of this either. We don't need to allocate anything. I guess guess in here... No, we don't even need that, really. Yeah. Yeah, we don't need to be setting those textures. Is this still working? No. Oh yeah, this location. Yeah, we don't need to be setting them here, because we're already doing that anyway. Yeah. Okay, so all of this goes away. That goes away, that goes away. Okay, this ID isn't necessary, that's not necessary. So that's not necessary, that's not necessary. That's not necessary. Okay, this texture is allocated, but we don't do anything with it, so I think we can just remove it. That we don't need. I mean, I don't think we need much of anything here. Except, well... No, I think some of it we actually do still need. Yeah, so this part is still necessary. Okay, interestingly enough, so we don't actually do anything here in the chunks. Yes, we don't actually have to iterate through the chunks. Except that we need to advance through them. Okay, so we almost get rid of everything Sprite related. Almost. The only thing that's left is this animation stuff. And yeah, we can also just put that into the assets. Yeah, where is our animation stuff? Here. Alright, so that's just animation info, essentially. And we can put that in here somewhere. Alright, well, each file is an animation. It's one file per one animation. So wherever it is that we are iterating through, at whichever point after sorting, right? After sorting, it's okay to start iterating through files and reading Sprite's files and stuff, like here. Yeah, Atlas locations and also animations. Except this should be file infos. Length. Because animation IDs will be written out in the same order as the files in that array. I'm pretty sure. So that should be initialized to 0. Animation struct should be taken out to common. So animations are allocated on the arena. And then we just go through do this. Here. No, this should be done for each file. So this animation ID is just file info index. Frame count is pulled from aSprite. Duration is allocated. Oh, well, that's interesting. How is that gonna work? So frame count is pulled off the file, that's fine. Duration is allocated, and then duration is set. For each frame. Okay, that works at least, so that's something. Okay, so animations are set, animations are... So we allocate the arrays, because we have an array of animations, but within each of those arrays there's a subarray of frames. And yeah, if we just pack all that in to the asset file, which is kind of where it belongs. And then we'll actually still need to reconfigure some of this. Although, actually, well, I mean, we do have the asset data, right? We do have the asset data, just kind of always available. So let me revert this. Let's revert that. Since we have the asset data always available, yeah, writing that out is actually not going to be that simple. Because an array is supposed to have entries of the same size, but here is that like heterogeneous. So it's almost like we want to go through this asset data and reconfigure. Well, alright. The main thing is that we have the animations and all the data associated with the animations. Suppose let's make sure that we have it. Animations. Yeah, seems to be fine. Animations 3. frame count 2, frame durations 1, frame duration 2. Yeah, that seems correct. Alright, how are we gonna write that out though? Into the asset struct. Well, we could just have an array of durations, and then for each animation have like bounds within that array that they belong to or something. Well, actually, we don't even need that really. What we need is an array of animations. Well, we're definitely gonna need to put all the durations next to each other. And for each animation, we're gonna have to say how many frames. Just the first frame and the last frame. Yeah, just the first frame and the last frame. In that array. Right, so what's that gonna be like? Struct like animations array, and then this is gonna have a number, like how many animations we have. 3. And this is gonna have, no, actually, no. Animations, and this is gonna have like F32 durations, and then however many, like 4. And then, well, I guess float. Durations, and then struct to first, last animation, and this is an array. Something like this. It's not gonna be something like that. Alright. Asset begin struct asset end struct animations asset add field add R field. Of course, the problem with array field is that durations data animation durations and count, well, yeah, I mean, we have the animations. We don't really have animation durations though. But we can pull that out. F32 animation durations. Arena, alec, and 0 array. Arena, i32 file infos length. Then for i32 animation index is 0, animation index is less than file infos length, animation index plus plus, then animation is animations plus animation index, and then, well, actually it's not file infos length. 32 animation to struct pointer length animation durations is that, then iterate through and go animation durations length plus equals animation frame count. Then do animation durations pointer arena alloc and 0 array. Arena type is f32, count is animation durations length. Then iterate through them again and just do a memcopy. Destination nearest pointer plus animation durations length. Source animation frame duration milliseconds. Size of f32 times animation frame duration frame count. So do a memcopy right there, and then do, no, actually it's not length. Capacity. Well, I mean, if we're gonna have capacity anyway. Capacity is 1024 or something. I mean, if we're gonna have that, then yeah, let's just do it this way. Animation durations pointer is arena alloc and 0 array. Arena f32 animation durations capacity. Then iterate through, and then just do for i32 frame index 0, frame index is less than animation frame count, frame index plus plus, r push animation durations f32 duration is animation frame duration milliseconds frame index. Pull that out and push it into the animation durations here, like that. Okay, does that compile? Durations float. That. Float durations 4. There's 4 of those, yeah. Yeah, now it's just to write in the first and last for each animation. So this is gonna be something like asset begin struct yeah. Well, no, yeah, we do kind of need this. And then yeah, because that's gonna be copied with iterations, but then the first last thing. Type def struct first last. First last. First last pointer length capacity animation delimiters or something. Capacity is that. Delimiters pointer is okay, so go through and do this. So yeah, our push into that, and then we just go first last. FL is, well, first is what? Animation durations length, right? So that's first, and last is just that minus 1. I mean, I suppose I should assert here that animation frame count is at least it's greater than 0, at least 1. Our push animation delimiters value FL. Assert animation durations length is animation. No, actually, they're different lengths. Yeah, they're different lengths. Okay, so now we have the delimiters. Asset begin struct data B. Should we just have a first last in there, or well, I mean, it's not really a struct. Hold on. Asset add array field. So that should just be struct i32, well, int, whatever, first, last. Hopefully that's what I'm writing. Yeah. Int first, last, delimiters. And this is going to be animation, delimiters, pointer, and length. Something like this. Okay, so now we read that in. We read that in. And I think that should be enough for us to build out our own animation array. Because the limiters, really those are the animations. Right? So, alright, so we can go for animation index is 0, animation index is less than animation ID count, and animation index plus plus. So that is animations plus animation index, and then okay, so this animation frame count is asset data animations delimiters animation index. I suppose assert that array count asset data animations delimiters equals animation ID count. Last minus first. Plus 1, because it's inclusive. And animation frame duration in milliseconds. I mean, this is really frame durations. Is asset data animations durations plus first. So it's that. Will compile. Oh yeah, that's in here. Frame durations. Okay. Okay, now that compiles. Of course, we need to not modify it anymore. course, this cumulative frame counts. Yeah, cumulative frame count is like, you only really need it to look up into the Atlas ID, whereas frame count, you kinda do need it to go along with anime. Yeah, I guess I'll keep it this way. Alright, so what's in here? In here is this stuff, so let's not do that. Four. Oh. Yeah, well, animation ID count isn't really 4 anymore. Because 0 is none, right? So alloc array alloc and 0, this one actually. Then assert that this is true and then start at 1. Well, actually no, start at 0. And I suppose this is gonna be +1. Yeah, like really this is where we're going to. Yeah, in this animation index, yeah. So it's animation index in the assets. That seems to be working. Well, maybe. We could verify. Is it like P or something? If we just make this be really large, 2000. Yeah, we should see that easily. Gonna have to recompile to repack everything. Run. Yeah, so we seem to be fine here. P. Okay, so that's 200. Alright, so that seems to work correctly. Yeah, this is kind of awkward though. Like having to allocate it and 1. Also, it seems like first last really should be in like a data structure, because we kind of want to refer to it in places. Let's just put it into common. Then this could be first last. And this could be first last. Delimiter is asset data animations delimiters animation index. Yeah, something like this. Alright, does that work? That does work, yeah. And okay, so the last traces of this, so that doesn't need to happen anymore, because we don't actually do anything here. Okay, so we just construct the atlas and the locations. And come to think of it, locations could just be figured out right here. There we go. Okay, those are the atlas locations. So that's all good. And those are the animations that we do need to construct them. Can't just refer to what's in the file. There is the sprites, not sure where those need to go. Okay. Atlas. Well, there's the atlas, and then I just put that in there. Into the GPU. Yeah, we don't actually refer to memory scratch anywhere, so we don't need this. Alright, so does this work? Yes. So let's remove a sprite then. From, okay, well, no, this is all fine. Okay, there's the asset data. There's the animations. There's the Atlas locations. Sprites, window, DirectX. And then the update. Yeah. Okay, we're down to like 700 lines in the main program, plus all of this in the common. Okay. Well, all of the ASprite stuff can now go into build. Okay, so what does common have? All of this is actually common. Yeah, all of this is actually common. Oh yeah, shaders. Yeah, but that's the next thing. So all of this would be... Yeah, that would be the next step, is to move shaders in. And then this will be the only file read that happens here. Well, alright. What's this? Build. Yeah, moved all this stuff in. STB. ASprite. Texture packing. Yep. Moved more stuff into common. Moved ASprite out of common, actually. That's good. Generated a bit more here now. Oh yeah, so we removed rectvac and image. We removed a bunch of things. Added this asset loading, nice and simple. We removed all this stuff. Checking in to see how the progress is going. Well, I've automated. I mean, I've put a lot of the texture creation, Atlas texture creation, into the build program. So now I don't have to parse ASprite files in the game. At startup, I can just read the asset file. I can just read the asset file. and use the atlas that's already there. Move atlas creation into the build program. Alright. And I'm done for today. Thanks everyone.